You might be asking where I'm at. Well, that's a good question. You got to watch it to find out. But today's video is all about picking the right camshaft for the job. So I've said it time and time again, camshafts are a give and take type thing. Today I'm down at Daniel Powell's place, Powell Machine, Powell Camshafts. We brought the Godzilla down here, been trying to get a plan together on that. But what brought us together was bad distributor gears. And so me, being me, you know, if I'm gonna go ahead and have a cam ground, you got to get the right cam for what we're doing. We're getting ready to spray a ton of nitrous on mixed up balls. And camshafts, while I said in a previous video I could spray a ton of nitrous on that cam, it's not optimal. You know, I don't want nitrous going out the exhaust. We're going to get into the technical aspects of camshafts and why, once you get to a certain power level of nitrous, you really need to have the right camshaft in it if you want to win. All right, so I've got YouTube extraordinaire Daniel Powell here. So this is Sammy's whooping stick. This is the big old smoke pole right here. That thing looks good. So let's talk a little bit. Look at that. Attention to detail, folks. That is why I'm here. Let's talk about camshafts and having the right one. So I'm a nitrous guy. I could probably spray a $150 on the cam that I have.
Oh, absolutely.
And not have a problem. Nah. But when you start getting around 300, maybe 400 horsepower worth of nitrous, why do you need to have a cam that's proper for it?
So what'll happen is, you know, just there's so much cylinder pressure and there's so much just extra volume that you got to get it out. And the only way you can do that is you got to give it more time, right? So we generally, on nitrous applications, we open the exhaust valve a little earlier and keep it open a little longer for blowdown time. And then like, and we've talked about this in other videos, like most power adders, you got to be real careful of the exhaust side opening acceleration because you're just opening under so much pressure. So long term, you know, if you don't pick the right lobe, you're gonna have valve train problems down the road. And especially with the boss head, with the big huge rocker arm.
Heavy.
Right, well, not only is it heavy, it's long and flexible.
Bingo.
So if you try to open the exhaust valve really fast with all of that cylinder pressure, stuff's just gonna blow up, right? It's just gonna store energy and then it's gonna release it in the wrong place and just all of that. So I feel like, you know, you determined your lobe separation.
Yeah.
I feel, looking at the events, I feel good about it. I think it's going to work great. We tried to tailor the intake closing really close to where you were now so we could maintain that dynamic compression. So we ended up, from where you were at, we ended up 5 degrees plus 5 on the intake center line versus, I think the other one was +4,
yeah,
I think. And you widened lobe separation a little, and you know when you widen lobe separation, it opens the exhaust valve earlier anyway, so that's a plus for you.
Talk about that, you know, lobe separation and power adders. I mean, a 108, that's not a nitrous cam.
Well, you know,
and you can use it, but
yeah, right. And generally speaking, with a lot of that stuff, and you know, I haven't done back-to-back testing, but we know what works from just experience. But something that I will say, and I want to be quick, don't want to drag it out, but something I will say that really surprised me, and we're going to do some more testing on it, is we did, just as a fluke, we did a 106 LSA with Eric Weingartner's 350 with a supercharger.
And that thing
made 1,056 horsepower.
Broke all of the internet laws.
Right. So having said that, would it have made 1,300 if we could have trapped some more cylinder pressure? That's the question. So we're going to answer that question because we're going to do another cam with the exact same duration. We're going to spread the LSA. that's going to get the events wide enough to get rid of all that overlap, and I'm hoping that it's going to answer a whole lot of questions. That because again, people get mad when I say this, but everybody's guessing. Yeah. And some people don't like that, but I say everybody's guessing. Some people just guess better than others. Right. And I am for sure guessing. I make this stuff up as I go. It's just been working pretty good so far.
Well, you're relying on your experience of what you witnessed.
Exactly. And again, I don't know all things, but I think I understand enough to get myself in trouble. So we make predictions, and most of the time we do pretty good. Sometimes we don't, and we have to go back and eat some crow, but that's okay because I got a cam grinder and we can make another one. That's right. But I feel confident we put 15 degrees of split in this thing. It's like
260, 274. Let's look at
let's just look at the cam card here. It is 258.3 on the intake, 272.6 on the exhaust. With lash, we 698 at the valve, and it's a 110.9 LSA.
111.
Right. Yeah, them points matter. No, I'm teasing.
Some people are.
I'm teasing at 104.5. So we ended up +6. That's what it took to get
where we
where we needed to be, and that give us a 76.56 intake closing. And I think I figured your other cam, and it was like 75.
Yeah.
So we were trying to and I don't remember what dynamic that give us.
Right.
But it was a good number.
Yeah.
And you got to keep that dynamic in check or you'll get in trouble. But I think yours was low enough, because anytime you go bigger with the cam, right, the intake valve is closing later. And you just, you can advance, but just like, all the lobes are hooked together. So it's moving everything. So that might not be optimal.
You're robbing Peter to pay Paul.
Right. So, but when we grind the cam, we can put it closer to where we want to be. It's not unlimited, right? But I feel good from what I've seen in the past. I feel like that grind, and I went back and watched some of the videos on the cylinder heads.
Yeah.
Man, there's some nice heads right there.
Yeah, they're pretty slick.
So I feel like that head is not going to need nearly as much cam as one may think, just because the head is really efficient. So I think you'll be good with probably up to 350.
See, our goal is to go 5s because, after all, it's still a 4,200-pound truck with twin I-beams. Okay, let's get real here.
Yeah, well, you gotta put that thing on a diet. You know?
Hey, what about me? I'm working on it.
Hey, we all working.
Hey, that's why Micah drives it.
There you go. So, but I feel, and we put some new designs that we done about 3 years ago. So they're pretty late model designs. They're asymmetrical.
All right, so let's talk about distributor gears and compatibility, because that's a big deal.
So one thing that we do always is, if you look on our cam card, it's going to tell you the firing order of the cam, and it's going to tell you what kind of gear you can use with the camshaft. So with this cam, it says to use a steel, bronze, or composite gear on the distributor. And there are, Morel, the parent company of Morel has a iron alloy gear that's melanized that is supposed to work with any core material. I personally haven't tested them, but tons of other people are using them and having good success. But what we've been doing is we've been using melanized steel gears.
Oh, okay.
And so, and just to clear up some confusion, because
there's a difference.
Right. So melanized is like a slang term. It's actually melanite QPQ. That is a surface treatment process. So anything can have that process done. Steel, iron, on and on.
Doesn't matter.
Right. But it's a surface hardening process, and it's a or like a rust corrosion inhibitor also. So you can melanize steel or iron. But we've had good success with steel gears on steel cams, and the core manufacturer recommends a steel gear for a steel cam. Now bronze is fine, but on a Ford, we see problems. On a Chevrolet, I can run a bronze gear on a Chevrolet for 6 seasons, no problem. But a Ford, I mean, you might not get 6 days. I mean, it's just, you know, but, and you said you done it, but another FYI is the front oil gallery, always drill a 16th hole in that plug, because it'll squirt oil right on the distributor gear.
I even measured the distributor gear on the shaft and all of that, and it's like, man, Yep. And another thing that we do, and I've got it for Chevrolets, I just don't do a lot of Fords engine building. But one thing that we do is we've got a little aluminum bar that bolts on to the shaft on like MSDs and stuff. And we'll actually put an indicator and check the backlash. Okay.
And so, because if you get excessive backlash, it's a problem, but it'll also break up at higher RPM if you get a bunch of backlash. So we always try to check the backlash and make sure, and we've got, for Chevrolets, we've got 1, 2, 3, 4, 5, up to 10 thousandths oversized gears to help with that.
That's good stuff. So you might be asking about the camshaft that was in it. Per the cam card, it was meant for 1.6. I put 1.7 rockers on it, you know, because that's what I have with those big old Hemi heads. But it's 674, 705, 259, 263 on a 108. And it was installed 3.5 degrees of advance. So with that being said, you had to go back and watch the other videos of what I actually seen at Lash, but you get the idea. This cam is somewhat similar, but yet much different, because here's the thing. We could put a camshaft in that motor that would probably make way more power, shoot for the moon, but since I drive this thing on the street, it's important having load designs that will live and not eat up valve springs. Just watch Drag Week or anybody else in the valve train failures that they have. I don't want that, because I drive this thing. Now, some people say I'm crazy for driving solid rollers on the street, but if you do it right, and if you have the right lobes and you have the right spring controlling the valve train, you can do it. Now this is just me, but I actually, every time I change the oil, I pull the valve covers off, check for lash. Sometimes I don't use a filler gauge. Sometimes I just feel them to make sure nothing is moving, because like Daniel has said in his videos, if you see variations in lash, you've got a problem. And I'm all about trying to catch the problem before it destroys a whole engine. You know, so I'll take 30, 45 minutes of my time checking those valves to give this guy a peace of mind. And so that is why I'm down here with Daniel Powell, because I've watched his videos. I know how thorough he is when it comes to his quality. You know, with the cam doctor, verifying that what he's seeing in the grinder is actually what is going out the door. You know, because that is so important these days. You don't want to get a camshaft that says one thing on the cam card, and you really don't have a clue as to what it is unless you physically check it with a cam doctor, right?
And that's why we always send a cam doctor report. We don't just write what we hope it is on a piece of paper.
Well, and something else too, like when you get a cam card from one of the big cam companies, it'll say upgrade distributor gear. It will not tell you what gear to run, you know, most time on the cam card. Which is crazy.
I mean, that's setting the customer up for failure, basically.
Yeah, so all of this data that's on this sheet of paper right here, that is priceless. And that is why Micah and I drove 2 hours down here to get the new smoke pole for mixed up boss so that we can wear them out in truck wars, and he can begin development work on this right here. Now, Daniel is going to have some awesome comparison videos. This video for him will probably blow up, because going to do some in-depth comparison between this and LS, and the results is really interesting. At least it is to me. And I think we discovered, sitting here talking amongst ourselves, we're not going to have to reinvent the wheel and trying to make this thing make some serious horsepower. What do you think?
Oh yeah, I mean, the head looks absolutely awesome. So for real, you know, the head looks really good. I'd love to get it. You gonna do some.
Yeah.
So once you get it on the bench, I'd love to know what it says for sure.
Absolutely.
But just what I see, it's gonna be good stuff. Because like I say, ultimately, structurally, it's built similar to a LS.
Right.
So there's no reason why with a much better cylinder head that, I mean, it's a no-brainer, right? Yeah. I mean, the only thing that'd be better if it was aluminum.
If it was aluminum. But he's going to have some killer stuff on his channel about the cylinder wall thickness and stuff. We were shocked. I'm shocked. I'm happy.
Yeah,
so,
for sure. Yeah, we'll sonic all the cylinders and show you what that says. But we checked a few here just while we were looking at it, and definitely it's good stuff. So yeah, we're gonna go through all of that. We're gonna do some comparisons on lifters and push rods and rocker arms, and we'll do all that.
So that's the kind of stuff you get on Unity Motorsports Garage and Powell Machine and Powell Camshafts. You get real world tech as it's happening. So me and Micah, we got to head up the road at I-85. So until next time, this is Andy from Unity Motorsports Garage.
Micah from Gas and Automotive.
Daniel from Powell Machine.
Next YouTube superstar. We will catch y'all later.